So we'll talk about vector fields. So the idea of a vector field, so vector fields, at least so far, is a function f of xy. And for each point xy in the plane, it gives you a vector. So it actually outputs two things, another x and y. And that's why this f has a vector notation above it, because the output is a vector, not a scalar. So for instance, maybe our favorite f of xy is the vector field x comma y. That means at every point, well, it tells you what vector you get out. So for instance, what? Here at the point 2 comma 1, right here. I don't know what it should be, so I'm going to plug it in. F of 2 comma 1 is 2 comma 1. So the classic way to do that is to take the tail of the vector, put it at the point you're at, and then just draw the vector coming out of there. So this is the vector field for that. And we sketched this the other day, so you might be able to just sketch in a few more, see how things are going. A nice technique actually for vector fields, that one's not so good, it should be coming directly out of the origin, is kind of, sometimes the arrows get a little big, so you could scale them all by a factor. Like you could scale them all by a factor of 1/3 just so that there's not, so this doesn't look so much like feathers. So there's that. And this would be in all the quadrants. Please don't forget that there are other quadrants other than the first quadrant. All the quadrants matter and are important to us. So it keeps going like that. So what you should think of, I'm telling you how you should think about it. You can think about it this way, and then if you want to think about it differently later, that's okay. Is as like wind or water. So think about this as like you go out on the field, the one that's in the middle of the track, and it's super windy. And if you're at the point 2 comma 1, you'll be experiencing this kind of wind. And if you're at point -1 comma 1, you're experiencing that kind of wind. And so another way you can think about it is like, well, what if I just let myself go? And I stand at the point 1 comma 2, and I just sort of, just let the wind take me. Well, it would take me out this way. And since all these are radial from the origin, it would just take me out this way forever. So this is a flow line. And then you could think about if perhaps you weren't watching, you weren't paying attention, and you find that I was floating along this line, you might wonder, where was I before you started watching? You can sort of see that I would have come from the origin. So that's a flow line, and they help you to tell what's going on in the vector field. So you want to put representative flow lines all around, and I'm not going to do that because it's your homework. And so there's really 3 topics to multivariable calculus. There's derivatives, integrals, and calculus with vector fields. And so we're going to think about, suppose you're not just letting yourself go wherever, but you actually have a destination in mind. So for instance, you're here in the classroom 104, and you're interested in going to here, to Sharples, because you are hungry and it is lunchtime. You want to maybe go like this. And you want to know, is the wind going to help or hurt you along your path? Hurt you. Yeah, it's just, well, and mathematically we say it's really not going to do anything because it's just perpendicular to you the whole time. But you might think, so here, 0 effect. I know it probably would actually hurt you because you're getting this side wind all the time. But you might think, what if I instead go to, I don't know, Parrish or whatever, and then go to Sharples? How will it help? What will it do to me now? Yeah, it's going to hurt you there, and it's going to help you there. And probably they're going to cancel out, so you would get the same 0 effect. So this is called a vector line integral, because we're seeing how much it helps or hurts us along our path, and that's one of the big things that we're going to do. But now, just for now, we're understanding vector fields. Sound okay? All right.